my name is Sanskar Kumbar. I am a second year mechanical department student. In this video, we are going to learn about thermodynamic processes. Thermodynamic processes are an important part of engineering thermodynamics. In this video, we will understand four fundamental processes: isobaric, isochoric, isothermal, and adiabatic. Thermodynamics deals with the relation between heat, work, and energy. Whenever a thermodynamic system changes from one system to another, it follows a particular path. This change from one state to another is known as thermodynamic processes. To understand this process, we mainly look at properties such as pressure, volume, and temperature. Consider a gas inside a cylinder with movable piston. The state of this gas can be described using pressure, volume, and temperature. When the gas changes from one state to another, this property may change in a specific way, depending on which property remains constant or whether heat is transferred, and we classify this process into different types. First, we have isobaric process. The word isobaric means the pressure remains constant throughout the process. Here, heat is supplied to the gas inside the cylinder. As the gas receives heat, it expands and pushes the piston upwards. During this process, the volume and temperature change but pressure remains constant. Therefore, the defining condition of an isobaric process is pressure equals constant. In a constant pressure process, the gas can perform work and its volume increase. On pressure volume diagram, an isobaric process is represented by a horizontal line. Next is isochoric process. Isochoric means the volume remains constant. Imagine gas enclosed inside a rigid container that cannot expand. When heat is supplied, the molecule gain energy and move faster. Since the container cannot change its volume, the volume remains constant. As a result, pressure and temperature of gas increase. Therefore, the defining condition of isochoric process is volume equals constant. Because there is no change in volume, there is no boundary work done by gas. On pressure volume diagram, an isochoric process is represented by vertical line. Next, we have isothermal process. Isothermal means temperature remains constant throughout the process. Here, the gas expands while maintaining a constant temperature. As volume increases, the pressure decreases. For ideal gas undergoing an isothermal process, pressure multiplied by volume remains constant. We can also write as PV equals constant. This means if the volume increases, the pressure decreases accordingly. On pressure volume diagram, an isothermal process is represented by a smooth curve. A slow expansion or compression of gas while maintaining isothermal contact with its surrounding can approximate its isothermal process. Finally, we have adiabatic process. In adiabatic process, there is no heat transfer between the system and its surrounding. This condition is represented by Q equals 0. Imagine our piston cycle surrounded by insulation. When the gas expands rapidly, it does work on surrounding. Since no heat enters, the energy required from work from internal cause of the gas. Therefore, its temperature can decrease. During compression, the opposite can happen. Work is done on the gas, cause its temperature to increase. For reversible adiabatic process involving an ideal gas, the relation can be written as PV to the gamma equals constant. On PV diagram, the adiabatic curve is generally steeper and corresponding to the isothermal curve. Let's quickly compare these four processes using a pressure volume diagram. For isobaric process, the pressure remains constant, so we get a horizontal line. For isochoric process, the volume remains constant, giving us a vertical line. For isothermal process, temperature remains constant. The following curve follows relation PV equals to constant. For adiabatic process, there is no heat transfer, so generally curve is steeper than the isothermal curve. So let's quickly recap. Isobaric equals constant pressure. Isochoric equals constant volume. Isothermal equals constant temperature. And adiabatic equals zero heat transfer. These four processes form an important foundation for understanding thermodynamics and its application in mechanical engineering. Thank you all for watching.